Welcome to the 24th section of the course of Express System with C++ and Qt. My name is Carlos, and now we're going to continue with the implementation of the Workspace. To begin with, we need to start talking about the constructor. I did already to explain it faster. So the point here is that we need to change the member, the tree builder pointer, to be a cons pointer pointed to a cons variable. Is that clear? And the workspace will have the same idea. And in the implementation, the same idea, but we also are going to use the initializer list. That is pretty straightforward, and that's it. That's everything that we need to do to the constructor. So the next function will be void workspace reset. Okay, the deal with the reset is that we're going to use two types of containers. One of them will be very used, will be often used, and the other ones will not. So for the very often users, we need to define functions, because as you might know this, and some of the principal rules of the programming is to have some members to be encapsulated. So it's really important to make these members private, to don't allow the user to corrupt them, and just have an interface to those variables. So the interface are these functions, and the content that we're going to use very often is the rules, antecedents and consequence, conclusions, denied atoms, and that's it. And the other ones we just will call the clear. Pretty funny, right? Irrelevant. There is no relevant rules. What's going on here? Okay, let's find relevant rules. It's a Q vector commented, and is entry, and we will call it relevant rules. Okay, relevant rules dot clear. Okay, that's it for this function. And the next one will be reset rules. Well, this is a function, a specific function, and the point in this one is to just reset the rules, but it's not just that simple to just call clear and I'm done. Now we need to give to the inference kernel something to work, and the something that we need to do is to clear it and put the newer knowledge base and define the rules, because the rules are very important. For each rule is a row, and then we need to define in this way the reset rules. Was it clear? I don't think so, but I need to explain it in more detail. So as I say, the first step is to make clearance, then iterate all the knowledge base with the function getTree. And the problem here is that we haven't defined the getTree function, so we need to define it in the block compiler. Here. And this should be public. Let's do this. I'm pretty sure that QVector is just calling the append function. You might ask, what's the append function? Well, do you remember when we are discussing about QVector and QList, the difference? If not, just look at the previous video. And the point is that we need to use QVector because it's faster, has better implementation than QList, and the difference between them is that QVector should be used when you are appending or prepending elements. It is inserting, eliminating from the beginning or the end of the container. And the QList should be used when we are inserting things in the middle of the container. So in this way, we look at find uses, we're just appending. And that's the reason that I changed the QList to the QVector. Was it clear? So I would like to make it faster, and I know that in the product node we have defined an interface function called get type. This is our cons. To make clear that everything is right. It's not. What's going on here? Oops. List tree. Compile again. Not. Okay. Let's continue with this. MPTB getTree all the knowledge base. And what if we want to use the for each function? I don't think so. I prefer this one. So we're going to iterate all the knowledge base, and we also say, okay, I want for each element in the knowledge base identify or filter only the no type implications operations and append them in the rules. So curious way to explain this is that, as you might see, we're just filtering the implications and put it in the rules container. It's that easy. Next is the reset antecedents and consequence function. This function is pretty handsome, and it has a lot of things to explain. So let's, as the last one, reset rules function, we also need to clear it. But in this way, we're going to clear the antecedents and consequence values of and it's a function that I like to show something interesting is that we can define, you maybe know this, but if not, we can define different variables inside the for statement. So it's less that rule type size and rules is first. If you want to know where is this, is in the prop node header. Rules. Okay. This is for the antecedents, and the consequence is pretty much the same. So I think that you got the idea why I'm using the reset antecedents and the merge the antecedents and the consequence in a single function. And the only difference is that we are calling the first and second function. Let's say to the pick atom entry that we're saying to the pick atom that this entry is an antecedent of a rule, and this entry is the consequence of the rule. Sorry for the readable of the function, but if you see in the pick atom declaration. Where is it? Here. The third parameter is a bool, asking if it's a consequent. We can use true, false, true. So you might know this. No, thanks. Let's explain it. Just clear. In all the rules, we're going to define which ones are are antecedents, which ones are consequents. Let me just give you an example of this. A, B, and implication C, D. Okay. The compiler will start from the right to the left. So in this function, the first rule will be this guy. This is going to prove the C to the antecedents and the D to the consequence. After that, the next loop would be something like this. We replace with the AND operation the half expression, and now we're comparing this guy. This is the next rule. We're comparing. Oh, sorry, I'm lying, because we're just saying duplication. Never mind. It's pretty easy. We're just saying, okay, we're differentiating the rules from this arrow. I say, okay, this is the antecedent and this is the consequence. And what was the thing that I was explaining, I was incorrectly explaining, is the big atom function. But we're going to see that function until the next video. But what I want to told you that this function is eliminating the necessity of having duplicate code, because you can see the only thing that is changing is this part and this part, and we're just saying, okay, it's antecedents and or is a consequence. So I really like this function. And I think that this is the end of the video, and in the next one we will continue with our implementation of the workspace with 3 last functions. So share both up and comment the video. Also please check our website givetext.com.mx. So thank you.